So guys, I'll be teaching you today the significance of magnitude plot and phase plot. So before that, we should know that what is a linear amplifier and why do we use it. So consider a voltage source. It's a sinusoidal voltage source with magnitude of Vi and angular frequency of omega. Consider this as a linear amplifier. I'll write as linear amplifier with output, and basically it's connected to the ground. So the resultant here, I'll consider it as V out is equals to V naught sine of omega t plus phi. Observe here that the angular frequency remains the same. V naught is basically the amplification of Vi. So if you generate a transfer function, that is t of omega, see basically a transfer function depends on omega. So t of omega is equals to V naught by Vi. So the thinking, what is the transfer function here? So basically the transfer function here tells about that if there is an input of Vi, consider the box as a magical function that transforms a input quantity into a quantity called V naught. This is the transfer function, and V naught is greater than Vi. Okay, so this is the function of linear amplifier. So I'll jump on to the magnitude plot and phase plot. So basically, what is magnitude plot? So it is the graph between omega and the magnitude plot is the graph between omega and the voltage gain. So voltage gain here is 20 log of V naught by Vi. So as we saw it later previously, that the V naught by Vi is t of omega. T of omega basically is the transfer function. I'll write a modulus here. So if you plot a graph between omega and AV, then you will get a graph something like this. So basically AV is, I'll write it fully that you guys can understand clearly. This is the y-axis, this is the x-axis. So you'll get a graph like this. Extend it here, okay. So if you increase the frequency, you will see that initially there is an increase of voltage gain. After some time, the voltage gain remains constant with the increase in the frequency, increase in the I'll say the angular frequency. And after a specific amount of bandwidth, this is the bandwidth I'll consider. The voltage gain again decreases. So your bandwidth is omega 2 minus omega 1. Basically bandwidth omega 2 minus omega 1 is the angular frequency, the range, the period of angular frequency where the voltage gain AV is maximum.